Howdy, howdy, this is Mr. Potter. In our Unit 1, we talked a lot about data, how we can refer to data, how data can be used to store text, or how it can be used to store graphics. Also, how it's encoded. We can encode it using a binary system, hexadecimal, or even octal. But the question then arises, what do we do with multiple pieces of data? And so I actually want to start with the idea of what is a list. So let's say that I'm going shopping and I need to put some things on my list. So I've got milk and I've got juice and I'm going to have bread and I'm going to have butter and I'm going to have some lunch meat and I'm going to get some mustard. So I'm making items on this list. I'm adding items to it. And I can say, you know what, I just bought butter last week, so I really don't need that on the list. And I probably should get some mayonnaise as well, and some lettuce. So the idea is that a list is going to be something that we can add data to and remove data from. And I don't necessarily know where I'm going to add it. Maybe I want to make sure that I take this bread and put it at the end. And I want to take this lunch meat and actually put it closer to here because this is all of my cold stuff and this is the stuff that I don't have to keep cold. So if this is a list, then the question I can ask is, what is a list? So in computer science, we actually have objects called lists, and lists are what we call a data structure. In other words, when we're talking about a list, we're going to have some collection of data values. And what we'll be able to do with these data values is we'll be able to add, so we'll be able to append to the list, so I can add another thing to the list. I'll be able to remove an item from a list. Maybe I can even insert an item into the list. Or, I can also find out what the length of this list is. So here my length is equal to 6. So I have a 1, a 3, a 2, a 5, a 6, and a 7. So when I talk about a list as a data structure, I'm talking about something that a computer uses to accumulate data. Now, one of the things that's kind of important is that they all need to be the same data type. So in this case, all of my data types are numerical. In the case of my shopping list, all of my data types were going to be text-based. I could have a file that has a collection of graphics in it, in which case this list of data would be a graphical type. But a list has to have all of our data in the list being the same type. And we should have a way to change the items. I can either change the items by adding, what we call appending, or I can remove, or I can insert. And I should be able to tell about the list fairly easily. The idea is that I should be able to look at a list and tell how many objects are in the list. So we're going to talk about how we're going to deal with lists in this class, because the way that the Computer Science Principles AP exam is set up is that it asks questions without having the idea of what exactly is in the list. And actually, we have no idea what computer language is even being used. So we use something called Pseudo Code. And so we say Pseudo Code. This is not a real code. This is just a construct that kind of explains the nature of what we're trying to do without using Python or C++ or Java or any other computer language that's out there. So it's supposed to be language independent. So that's why we use the pseudocode, because it's language independent. Language independent. However, when I'm looking at this, there's certain pseudocode that's going to be used on the AP exam, and one of this is an assignment statement. So what I'm doing here is I'm assigning. So I've got a list called list, and at this moment I have 4 boxes. 1, 2, 3, 4. It contains a 3 and a 4 and a 5 and a 6. So this is my list. And what I've essentially done is I've created a data structure with 4 pieces of data in it. So now what I want to do is I want to talk about how we manipulate it. Remember that we talked about several of the things we can do, and one of the first things that we're going to be talking about is append. So if I were to take my original list, which currently has a 3 and a 4 and a 5 and a 6 in it, and I do this append, let's say I do append, and I've got my list, and I wanted to append a 7 to it. Well, what this is going to do is it's going to make this 1 longer, and in that new cell that we've created at the end, I've added the data value of 7. What's important to remember is that when we append at the end. So in other words, the end is going to be at the last spot that's available. Actually, it's got to be after the last spot that data is currently in. So this is our append statement, and I can always take a list and I can always add stuff to the end of the list. The next thing we have is the remove. So let's say that I've got 3, 4, 5, 6, and 7, this list that we've been appending to. And right now 3 comes first, 4 comes next, 5 comes next after that, 6 comes after that, and 7 is the last element in our list. So if I tell it to remove list, comma, 2, this 2 is actually the second position. But something that's important to note is that the computer actually starts counting at 0. So this is my 0 position, this is my 1 position, this is my 2 position. And when I say remove, this box actually goes away, which means this is no longer position 2. This is gone, completely obliterated. This is now a position 2, and this is position 3. So if I was to run this command again, remove list, comma, 2, then I'm going to go to position 2 and completely obliterate this box here. So now that this is gone, this is now my new position 2. So with the idea of remove, I can remove at an indicated position, but it's important for me to remember that I'm starting at position 0. 0 is always the first position, the index, if you will, of our list. So we can append to the end, and we can delete anything in the middle. It sure would be convenient if we had a way to kind of put something into the middle. And indeed we do. We have something called insert. So I'm going to take this list that we have, which currently has 3 elements in it. It currently has a 3 and a 4 and a 7. And what I'm going to do is I'm going to insert into my list at position 4, excuse me, not position 4, I don't have a position 4, I have a position 0, I have a 1, and I have a 2. But I want to insert at position 1 an 8. In other words, when I'm done, this will be the new position, and it'll have an 8. And everything else will move down. So in other words, this 3 is going to stay here. That's still in position 0. Position 1 will have the 8 that I'm inserting. And then everything else gets moved down to a new position. So now position 2 contains a 4, and position 3 contains a 7. And then if I want to insert list, comma, 3, comma, 9, then I'm going to have a new list. The 3, which is in position 0, stays. The 8, which is in position 1, stays. 4, which is in position 2. But now this position 3 has a 9 in it, and my 7 moves down. And I can even insert my list at position 0. I could insert a 10, in which case position 10 now, position 0 now contains the 10, and all of these other positions get knocked down. So 3 is now in position 1, 8 is now in position 2, 4 is now in position 3, 9 goes to position 4, and now the 7 is in position 5. Again, it's important for us to remember that our first position is position 0, and that means that our length is always going to be one more than the index of the last position. And that's important because when I talk about the length of a list, the length is always one more than the last position. So if I take a look at the list that I have, and the list that I have currently has, let's see, has 6 positions in it. It has 10, 3, 8, 4, 9, and 7. So 10, 3, 8, 4, 9, and 7. So this is position 0, position 1, position 2, position 3, 4, and 5. But really what I've got is 1, 2, 3, 4, 5, 6 boxes. So I would say that my length of my list is equal to 6. So I have a way to figure out how long this is, and it's going to be important because when I need to actually go through this, I can go through this one box at a time. And one of the ways that I can do that is by referencing what's in a particular box. Excuse me. So if I go over here to my list, which has a 10, 3, 8, 4, 9, and 7. So 10, 3, 8, 4, 9, and 7. And if I wanted to display what was in list sub 1, it's going to go over to list sub 1, box 1, and it's going to print a 3 on the screen. If I later on ask it to display what's in list sub 4, it's going to go 0, 1, 2, 3, there's box 4, and a 9 will show up on the screen. So this allows me to talk about what's in a particular box rather than thinking about data as a whole. So I don't have to worry about this being a data collection. I need to think about this as being an element inside a collection of data. However, there's going to be opportunities where we're going to need to go completely through a list, and there's a way to do that that's specifically designed for this. We have a for each loop. And this idea behind a for each loop is that whatever data is between the open and closed braces, this data is going to be run each time for each piece of data in the list. And what happens is usually data is my thing that I'm dealing with. So let me erase that real quick. I didn't want to put that there. But what I want to do is I want to display data. And if I do this, then the first piece of data is the 10. So a 10 will show up first because that's my first piece of data. Then the 3, then the 8, then the 4, then the 9, and then the 7. So this loop allows me to go through the data one piece at a time and treat all the pieces of data equally. All the pieces of data will be subject to whatever code lies between this. Now, we have talked a little bit in our Scratch program about how to put together codes in blocks. And what happens is this is basically one of those yellow loops that we have to kind of put pieces in. So this is one of our yellow control blocks that we had to put other things in, like making it move to a particular location or making it make a certain sound whenever the sprite moved. And we're going to do this for every piece of data that we had. So now that we've got the basic idea behind a list, we're going to talk about what we're going to do in this list. So keep in mind that once I have a list of data, there are really two things that we're going to want to do with it. One is that we're going to have to be able to find a particular piece of data. And one of the easiest ways to do this is just start at the beginning and keep going until we find what we're looking for or until we run out of data. And the second thing that we're going to want to do with data is we're going to want to sort. And the sorting and finding actually goes hand in hand for some of these things, because sorted data is a little bit easier to find. If you want an example of that, think about trying to find a word in a dictionary, or trying to find your friend's phone number in your list of contacts. So if it's sorted, it's going to be a little bit easier as long as you understand the sorting algorithm. Sorting by first name versus sorting by last name versus sorting by phone number, which would be horrible. So what we're going to talk about in the next video is we're going to talk about what is a linear search. In other words, how do we search data? But that's for next time. Once again, this is Mr. Potter. Thank you for watching. Have a great day.